Hello friends, welcome to this practical course on ETABS. In this lecture, we will be creating the geometry for our G+7 floors residential building. So first of all, open ETABS and click on this new model option. Here select built-in settings option. So here the display units that we will be using will be metric SI. So select metric SI from the drop down list. The steel section database will be Indian. The steel design code will be IS 800 2007 and the concrete design code will be IS 456 2000. So with all these built-in values, built-in settings selected, click on OK. A new window will pop up where you need to enter the grid dimensions and the story dimensions. So in our building, since we do not have uniform grid spacing and the grid spacing is varying, so we will be using the custom grid spacing option. So select custom grid spacing and click on edit grid data button. A new window will pop up where you need to enter the grid dimensions, that is the coordinate of all the grids from origin. So in our building we have 6 grids in the x direction. So here we have A, B, C and D. So we need to enter 2 more grids. So click on add button twice. So we have 6 grids from A to F in the x direction, and in the y direction we have 5 grids. So click on add button once. Now we need to enter the coordinates of all the grids, that is A to F and 1 to 5, and please note that the coordinate should be in meters. So in our building, consider this point as origin. So for grid A, the x coordinate will be 0. So this direction is x and this direction is y. So for grid A, your x coordinate will be 0. For grid B, the x coordinate will be 13 feet 3 inches, which is equal to 13.25 feet. So we need to convert this value into meters. As you know that 1 feet is equal to 0.3048 meters. So 13.25 feet will be equal to 13.25 times 0.3048 to convert from feet to meters. Similarly for grid C, from origin, the coordinate will be 13.25 plus 10.75 and multiply this whole value by 0.3048 to convert it into meters, and so on and so forth for grid D, E and F. Similarly, we need to also enter the coordinate values for grid 1, 2, 3, 4 and 5. So for grid 1 it will be 0 since it is at origin. For grid 2 it will be 5 feet 4.5 inches, which is approximately 5.25 feet. So again it will be equal to 5.25, and to convert it into meters it will be 5.25 times 0.3048. For grid 3 it will be equal to 5.25 plus 10 feet 7.5 inches, which is approximately 10.5 feet. So 5.25 plus 10.5 and multiply that whole value by 0.3048, and so on and so forth for grid 4 and 5. So let's enter all these values in ETABS. So the x coordinate of grid A is 0. For B it is equal to 13.25 times 0.3048. Press enter. So this is a great feature of ETABS where you can perform multiplication, addition, division or subtraction in ETABS itself. For grid C it will be equal to 13.25 plus 10.75 and multiply this whole value by 0.3048 to convert it into meters. Press enter. So let's add other values. Similarly, we will add the grid dimensions for 1, 2, 3, 4 and 5. So with all the values entered, click on this OK button. Now let's enter the story data. So in our building, the depth of foundation below ground level is 5 feet, which is 1.5 meters. The height of ground floor is 9 feet 6 inches, which is 2.75 meters. And the height of typical floor is 11 feet, which is 3.35 meters. So we can say that the total number of stories will be base story, which is nothing but the story which is below ground level, which is of height 1.5 meters. Then we have the ground floor, which you can see over here, which is of height 2.75 meters. Then we have 7 floors above the ground floor. Since the building is of G+7 floors, so we have typical 7 floors: 1, 2, 3, 4, 5, 6 and 7. And above the 7th floor we have a staircase cabin. So one story will be added for that. So one story for that staircase cabin or the lift cabin. So the total number of stories that we need to enter in ETABS will be 10. So let's add that. So total number of stories will be 10. Typical story height, which is 11 feet, which is 3.35 meters. And the bottom story height, which is nothing but the depth of foundation, which is below ground level. So that is 1.5 meters. Please note here that in our case, the typical story height is 3.35 meters, but the ground floor story height is 2.75 meters. So as of now, let's consider all the stories height as 3.35 meters. We will edit that after entering in ETABS. So with all these values, select this grid only option and click on OK. So here you can see that the ETABS has created plan view and a 3D view. Here you can see that the plan view is at an elevation of 31.65 meters. You can click on these down arrows or the up arrow to move at a different elevation level for plan view. Now let's edit the ground floor story height. So to edit that, click on this edit option and click on edit stories and grid systems option. Click on modify show story data option. So here you can see that the base, which is at an elevation of 0 meters, which is where the foundation will be there, which is in ETABS we need to have fixed support over there. Then we have story 1, which is of height 1.5 meters, which is nothing but the depth of foundation below ground level. Then we have story 2, which is nothing but the height of ground floor story. So in our case, the ground floor story height is 2.75 meters. So here you need to edit here as 2.75 meters. Okay, so click on refresh view button and click on OK and click on OK. So now we have edited our ground floor story height. Now let's add beams and columns, but before that we need to first of all create material properties and beam and column section sizes. So first of all, to define the material, click on this define option and click on material properties option. Click on add new material option. First of all, the region will be India. The material type will be concrete. So first of all, we are defining M25 grade concrete. So select M25 from the drop down and click on OK. So here, whatever the default properties are there, we will keep it as it is. That is weight per unit volume, modulus of elasticity of concrete, Poisson's ratio, etc. So here click on this modify show material property design data button. Here you need to make sure that the FCK value is 25 megapascal, since for M25 grade concrete FCK is 25. So click on OK and again click on OK. So we have created the material property for concrete, that is M25. Now let's create material property for steel as well. So click on add new material property. The region will be again India. Material type will be rebar. Standard will be Indian. And here we are defining HYSD grade 500 reinforcement for steel. So select that and click on OK. So default values we will keep it as it is. OK, and click on OK. Again click on OK. So now we have defined the material. Now let's define beam and column sizes. To do that, click on define button, click on section properties and click on frame sections. Click on CONC BM option and click on modify / show property button. First of all, let's define the property for plinth beams. So we will be using 230 by 300 mm size for plinth beams. So write your property name as B1 230 by 300. From the drop down, we will select here M25 grade concrete. The section shape will be rectangular. The depth of the section is 300 and width of the section is 230, since the beam size is 230 by 300. In the reinforcement, click on this modify show rebar option. Here make sure that since we are defining the property for plinth beams, so here the design type should be M3 design only, that is beam. The longitudinal bars that we will be using is HYSD 500. Confinement bars, that is ties, will also be of HYSD 500 grade. Click on OK and again click on OK. Now let's define the size for typical floor beams. So click on this add copy of property option. For typical floor beams, we are using 300 mm by 450 mm beams. So type here B2 300 by 450. Material type will be M25. Depth will be 450 and width will be 300. And in modify show rebar button, make sure that beam design is there, since we are defining the property for beam. Click on OK and again click on OK. Now let's define the section property for column. So click on again add copy of property button. First of all, we will be using 3 different sizes of columns. So first size will be C1 300 by 375. Material will be M25. Depth is 375, width is 300. In modify show rebar option, this time we will be using PM2 M3 design, which is of column, since we are defining the property for column. The longitudinal bars and confinement bars will be of grade HYSD 500. So click on OK option and again click on OK. Let's define one more property of column. So add copy of property. So the property name will be C2 300 by 450. So we are defining a column of depth 450 and width 300. Material will be M25 grade concrete. In the modify show rebar, make sure that column design is selected. Click on OK. Let's define one more property of column. So add copy of property. So property name will be C3 300 by 600. The depth of the column is 600 and width is 300. Click on OK and again OK. So we have defined beam property for plinth beam, typical floor beam, and we have also defined the properties for columns. Let's also define the beam property for secondary beams and cantilever beam as well. So select this B2 option and click on add copy of property option. So we will define the property name as B3. So for cantilever and secondary beams, we are trying with 230 by 300 again. So B3 to 230 by 300, depth of the property is 300, width of the property is 230, and in the modify show rebar, make sure that beam design is selected. So now we have defined all the beam properties and column properties. Now let's assign these. So first of all, to model these, there are many different options to model beams and columns. So I will show you all that one by one. So first of all is this draw beam option. So click on this draw beam option. Here from the drop down type, you can select frame. The property for the plinth beam will be B1 230 by 300. So select B1 230 by 300. So here make sure that at the plan level, the plinth level is at 1.5 meters. So make sure that from these arrows you are at 1.5 meter level. So click on this grid point and again click on this grid point. So here you can see that a beam is drawn from grid A to grid B. Again, to draw one beam, click on this draw beam button. With B1 230 by 300 selected, click on this point, click on this point. So this is how you can use the draw plinth beam option, draw beam option. Press escape button. Now this method is very much lengthy. It will be drawing the beams very slowly. So there is one more method. So first of all, select this beams by crossing window and click on delete button. Now there is one option which is called as quick draw beams / column tool. So click on that. From the property drop down, select B1 230 by 300. Here you can just click on this and it will draw the beam like this. There is one more method. So again select all these beams and delete it. So again select this quick draw option. With B1 230 by 300, you can draw beams by the help of this crossing window like this. So here you have beam. Then here you have beam. Here also you have beam. Here you have beam. And here you have beam. So this is how the plinth floor is looking like. Here you can see that this beam should be continuous. If you see, this beam should be continuous like this. But while modeling in ETABS, this beam is broken into two parts because there is one grid here. So ETABS is considering two beams instead of one complete beam. So we need to merge this beam. Similarly, we need to merge this beam also. And we need to merge this beam also and this beam also. So let's merge all these four beams in ETABS. So select these beams. Like this. Okay. Then click on edit option. Click on edit frames option and click on join frames. So now if you select, the whole beam is getting selected. So ETABS has now merged these four beams. Now let's model columns as well. So click on this quick draw column option. From the property, select column as C1. So at the corner, I am defining 300 by 375 mm size. So you can select, assign the column by having a crossing window like this. So at the four corners, I am defining a column of size C1, which is 300 by 375. Now let me select C2. So I will be assigning C2 here and here as well, and in this middle two grids, since the center to center of these grids 3 and 4 is very high, that is almost more than 6 meters, so I am assigning a higher size of column, which is C3 300 by 600 mm. So select this like with a crossing window like this, and here you can see that all the columns have been assigned. Now if you see, by default ETABS is orienting the column in such a way that the longer dimension of column is parallel to x-axis. Okay, but as per our column layout, all the columns are oriented in such a way that the longer dimension is parallel to y-axis and not x-axis. You can see here. Okay, all the columns, for all the columns. Okay, so except these four columns, 1, 2, 3 and 4, except these four columns, we have all the columns in which longer dimension is parallel to y-axis. So we need to assign the 90-degree angle to all the columns except these four columns. So let's do that in ETABS. So select all these columns, okay, like this. Except these four columns which I mentioned. Okay, you can see in 3D view as well, all the columns are selected. Okay, click on assign, click on frame and click on local axis. So we will give an angle of 90-degree. Click on apply and click on OK. So now you can see that all the columns are having longer dimension parallel to y-axis except these four columns, that is 1, 2, 3 and 4 column. Okay, except these four columns, all the columns are oriented perfectly. Okay, so now all the plinth beams have been modeled. Now we will model the typical floor beams. So click on this up arrow, click on quick draw beam option. So for typical floor beams, we are using 300 by 450 mm. Select B2 300 by 450. Okay, drag like this. We have beam here and one beam here. We need to merge this beam, 4 beams. So select these 4 beams. click on edit frames and click on join frames. Now let's assign columns as well. So what we will do is click on this down arrow, select these columns like this, okay. With all the columns selected, click on edit option and click on replicate option. Click on story option, and all the columns which are there in the base story, we need to copy it from to story 1 to 10. So select all the story 1 to 10 and click on apply and click on OK. So now in 3D you can see that all the columns have been replicated to upper stories. Okay, so click on up arrow. So we have added the typical floor beams as well. At the typical floor level, we also need to add the beams to support the partition walls. So if you see, we need to add one beam for this internal wall of this bathroom. So we need to copy beam which is connecting this column to this column at a distance of 5 feet and 3 inch from this internal wall and 3 inch from this internal wall. So 5 feet 6 inches total. So copy this beam over here at a distance of 5 feet 6 inches to support this internal wall of this bathroom. Similarly for this bathroom as well. Okay, so open ETABS, select this beam and this beam, press Ctrl C and Ctrl V from the keyboard. So in the X direction we need to move at a distance of 5 feet 6 inches. So it is equal to 5.5 feet times 0.3048 to convert it into meters. Okay, so press OK. Now similarly we need to add the beam to support this internal wall as well, which is at a distance of 9 feet and half, 3 inch from this side and 3 inch from this side, so 9 feet 6 inches total. So we need to copy this beam at a distance of 9 feet 6 inches for both these bathrooms. So open ETABS, select this beam and this beam. Okay, press Ctrl C and Ctrl V, and in the Y direction you need to go 9 feet 6 inches. So 9.5 times 0.3048. Okay, and press OK. Here if you see, both the beams cannot be continuous, right? We need to break one beam. So let's break this bigger beam. So select all these 4 beams first, click on edit and click on edit frames and click on divide frames and click on and select break at intersection. Click on apply and click on OK. So now if you see, the beam is divided into 4 parts. So out of these, this one beam should be continuous. So select this beam. So we'll keep this beam as continuous. So again click on edit frames and join frame. So now let me show you plan again. we need to add a beam to support this internal wall as well, which is at a distance of 3 feet 6 inch and 3 inch and 3 inch from this side, so total 4 feet. So we need to copy this beam at distance of 4 feet on the left hand side, and similarly for this bathroom as well. Okay, so select this beam and this beam, Control C, Control V. This time in the negative x direction, it will be minus 4 feet times 0.3048. Press OK, and we can ignore this beam which is of length 3 feet 6 inches. Okay, now let's model the beams to support this balcony as well. So the balcony here is 3 feet wide, so we need to have 2 cantilever beams and 1 simply supported beam. So copy this beam, and here this beam and these 2 beams. So this beam and this beam. Okay, we'll copy it, Control C, Control V. In the y direction it is 3 feet, right? So 3 times 0.3048. Press OK. So here you can see that the beam is copied. Here you can see that there is one beam here, and this beam is continuous. These 2 beams are continuous between D to F. So select those beams, click on edit frames and join frames. Now let's add the cantilever beam. So select this draw beam option. The property that you will select is B3 230 by 300. Click on this point, click on this point, press escape. Again draw that beam here. Okay, similarly draw other cantilever beams as well. So select this grid point and this grid point. Okay, if you see here you do not have any beam. Okay, so delete this, and the last beam which is here. So now you can see that all the beams for balcony have been created. We also have balcony on this side for the master bedroom. So here the balcony is 5 feet wide. Okay, so they'll select these beams of master bedroom. Okay, Control C, Control V. In the negative y direction, we will go at a distance of 5 feet. So 5 times 0.3048 to convert from feet to meters. Press OK. Select draw beam option and join like this. Draw beam from here to here. Okay, draw beam here to here. And here to here. Okay, so we have drawn all the balcony beams as well. Now if you know we need to also assign member and releases to all the secondary beams and simply supported beams. We need to release my mz in all the secondary beams as well as the simply supported beams which are resting on the cantilever beams. So select all the simply supported beams resting on cantilever beams, okay, as well as all the secondary beams. So these all are secondary beams. Okay, click on assign, click on frame and click on releases. So we are releasing my and mz. So in ETABS, my is nothing but m22 which is minor axis. 22 is the minor axis in ETABS and 33 is the major axis in ETABS. Instead it is y and z. Y is the minor axis in instead and z is the major axis instead. Okay. So release m22 and m33 and click on apply and click on OK. So here you can see that member release has been assigned to all the secondary beams and simply supported beams resting on cantilever. Okay. So this is how we will model the all the typical floor beams. Now we need to copy all these beams to the upper levels as well. Okay. So select all these beams. Okay, we do not have to select columns again because we have already drawn it. Select only beams. Okay, with all the beams selected, click on edit option, click on replicate, click on story option. So this is story 2, we want to copy it to above stories, that is story 3 to 10. So select all the stories 3 to 10, click on apply and click on OK. So all the typical floor beams have been copied to upper levels. Now if you see at the topmost level, we do not have a full slab, we only have a slab for the staircase cabin and the lift cabin. So we need to delete all the extra beams. So go to the top floor, that is story 10. Okay, delete this. Okay, so we have a staircase cabin and a lift cabin, right? On this area, in this area, that is supporting these 4 columns, we have a lift cabin, and here we have a staircase cabin at the top. Okay, so this is how our model will look like. If you want to see the elevation of grid C, it will look something like this. Here at the base we have fixed support. Okay, this is called as the ground story from base to story 1. Then from story 1 to story 2 we have a ground floor, and above that we have 7 floors, and above the 7th floor we have a lift cabin and a staircase cabin. Now let's model slab for our structure. In order to model the slabs, first of all we need to define the slabs. So go to define menu and select section properties and then click on slab sections. Select slab 1, click on modify show property button. The property name that we will be using will be slab 150. Slab material will be M25 grade concrete. Modeling type will be shell thin, and the thickness of the slab will be 150 mm, which is approximately 6 inches. Click on OK, and then again click on OK. Now click on this draw floor plan button. From the property menu, select slab 150. Here select the option as 1 story and click on 4 corners where you want to draw the slab, like this. As you can see, this method of drawing the slab is very tedious. So there is one more option of drawing the slab. First of all, press escape button. Now select quick draw floor plan button from the list. Now with this option, you can just click between this hollow space in order to model the slab. Now here you can see, if you click here, ETABS is modeling the slab between these grids. However, the slab over in this area is continuous. So here we will be using the normal draw slab option. So again switch back to this draw floor option and click on these 4 corners. For this portion as well. And for this portion as well. We'll keep this portion empty since in this portion we will have lift, and also this portion will be empty since this will be occupied by the staircase. So delete this as well. Now we have modeled our slab for the terrace level, that is at Z is equal to 27.7 meters. Now let's replicate these slabs to the bottom stories. So first of all, go to select option, then hover on to select, and then select object type. Select floors from the list and again click on select and click on close. So here you can see that all the slabs have been selected. Now go to edit menu, then select replicate, click on story. So what we want is whatever the slab that is modeled on this story 9, we want to replicate it to the bottom stories. So select all the bottom stories from story 1 to 8, click on apply and then click on OK. We will also have slab at the topmost level, that is at Z is equal to 31.05 meter. These slabs will be used to support our lift, and in this area on the top of this slab we will have our water tank. So we need to model the slabs in these two portions as well. So select quick draw floor plan button and draw the slab over here and here. So guys, this is how we will model our entire structure in ETABS. So if you like this, then please subscribe to my channel and also press the bell icon so you don't miss any future update. Thanks for watching. Bye for now.